Hi and welcome to the video. My name's Kane, I'm the founder of SEN 3D and the creator of the Ender IDEX kit. This kit enables anyone with an Ender 3 to add a second independent extruder. So you can print two things at the same time in duplicate or mirror mode. You can also print two different colours, materials, or even use two different nozzle sizes at the same time. To find out more about what the kit can do, just visit enderidex.com. In this video I'm going to take you through every step to install the kit on an Ender 3. I've broken the process down into 4 parts. In the first we'll be taking a look at the printer we're going to be upgrading. Next we'll install the motherboard, then the new X-Axis, and finally we'll calibrate everything and start printing. If there's anything this guide misses out or you feel that you need help with, just drop me an email and I'll be happy to help. So enough talking, let's get started. Part 1. The printer. So of course you're going to need an Ender 3 for this kit to work. Now it may also work on other printers based on a similar structure, but I can't guarantee it. In this case I'm demonstrating with a bog standard basic Ender 3, no upgrades whatsoever. It's got the original bed, springs, extruder and hot end. If you've made upgrades to your Ender with things like a glass bed, stiffer springs or a metal extruder, this will all work even better. The point is that none of this is a requirement for the IDEX kit to work really well. The other step I would strongly recommend before we get started is you print a baseline object. Now in this case I printed a benchy because why not, it's a benchy. But also because a lot of the test files we'll be printing later on also use a benchy. If you come up against problems with printing now, I'd strongly recommend fixing those before you try to install the IDEX kit. As you can see here, my benchy is looking great, so let's crack on and start installing the kit. Part 2, the motherboard. Let's start by cracking open the box and see what's inside. You've got the new spool holder, the second extruder, the second X-axis motor, pulley arm, a bag of small parts, the new wider X-axis extrusion, some parts, and the hot end motherboard box combination. So before we start, let's switch off the power and unplug the cable. We're going to remove the existing motherboard and its box. There are 3 screws holding the cover in, 2 at the front and 1 at the rear. Now remove the lid and unplug the fan. The board itself is held down by 4 screws you can see here. This is also a good time to remove the SD card so that it doesn't get lost or broken. Now remove the 2 screws at the front of the box. And finally, if you carefully place the printer on its side, there's a last screw on the bottom. The box should now come free and you won't be needing this anymore. If you take a look back at the motherboard, you'll see the cables are hot glued in place. Very carefully with a knife or other tool, pick away at this glue to free the cables. Be very careful not to injure yourself or damage the cables here. Take your time and pick away at it slowly. Next we can undo the screw connectors. Use a small flathead screwdriver to release each of the cables. Once all the cables are disconnected, you can put the board to one side so you won't be needing this anymore. You can also disconnect the cable from the display. Now carefully pull the cables out from under the printer to make way for the new box. Carefully place the Ender 3 on its side and slide the new box into the extrusion as you can see here. Make sure all of the wires feed through the gap in the extrusion at the bottom. Keep sliding it back and it should almost click into place. You can now tilt the printer back upright and make sure that none of the cables get squashed as you do this. Now the next part, we're going to connect up each of the cables. First up are the red and black wires from the heated bed. These are the thicker wires that come from the print bed and have no connectors at the end. These brilliant Wago connectors give you an excellent connection without the need for any tools or soldering. Simply flip up the clip on the empty slot, push the matching wire all the way in, and snap the clip back down. Give it a gentle tug to ensure it's firmly held in place, and ensure there's no exposed wire. Next, the hot end 1 cables. These are the tiny red cables that come from the hot end, and they'll be made of a thicker, slightly rougher material than the other wires. Give the strands a little twist to ensure they're all neat, and use the same Wago clips as before. It doesn't matter which cable connects to which, as this doesn't have any effect on the hot end. Again, give them a little tug to ensure they're held in place firmly. Next comes the parts cooling fan. This is easy as it's the only blue and yellow wire. Just plug it into the connector. Now the X-axis stepper motor. This should have a little orange X tag on it. Plug it in. And the same again for the Y-axis. We can also now plug in the power. I'm not doing this in any specific order. As long as everything gets plugged into the right connectors, you can do them in any order you like. We've got the Z-axis and the extruder, the Z end stop, the Y end stop, the X end stop. The hot end thermistor will be the 2 white cables that come from the hot end itself. The thermistor for the bed will be the black wires with no tag on it. We have the extruder fan. This is another set of Wago clips, and at this point should be the only wires left. Finally, the new display cable connects to the display. It plugs into EXP3, which is the connector closest to the box. And now if everything is connected correctly, we can plug the power back in and turn it on. All being well, you've just upgraded your Ender 3 to a 32-bit SKR Pro board. How easy was that? Go to Motion, Auto Home, and hopefully everything should move and home as expected. To close out this section, it's a good idea to run another test print to ensure everything is working as expected. The included SD card already has a Benchy print on it, which makes it easy to run. Unless you've been particularly aggressive with your printer, you shouldn't need to re-level the bed. Once you start the print, check to make sure the hot end and bed are heating up as expected. You should also keep an eye on the print to make sure nothing unexpected happens. This is probably also a really good point to remind you that if you hit any snags or get stuck, you can find more support at enderidex.com, or just drop me an email and I'll be more than happy to help you. As you can see, my Benchy came out great, so it's time to move on. Part 3, IDEX. We'll start this section by dismantling the existing X-axis. To make it easier, preheat the hot end, remove your filament and let it all cool down again. You should also turn the power off too. Now loosen the 2 screws keeping the spool holder in place, followed by the 4 screws for the top bar. We're going to need these again, so make sure you don't lose them. Now gently twist the Z-axis screw to raise the X-axis up. Don't do this too fast, as it could push current back into the motherboard and damage it. Once it's at the top, carefully remove it. Now to disassemble it, start by removing the belt as shown. Now the belt tensioner. Followed by the right hand bracket. and the left hand bracket. Finally, slide off the X-Carriage and you're done. Take the new wider extrusion from the kit and line up the 3 holes that are closer together with the left hand bracket. Make sure the side with the larger hole openings butts up against exposed screw heads on the bracket. Now you can use the same black screws to reattach the bar, but in the bag that came with the kit are 4 slightly longer silver screws. I'd recommend using these as the extra length gives a much stronger and more secure fit. You can now persuade the X-Carriage back onto the extrusion, followed by the new cable arm that comes with the kit. Slide it onto the back of the bar. Next, slide on the new second X-Carriage. This is starting to look pretty cool. Replace the right hand bracket and install the screw closest to the centre. You should again use the longer silver screws here. Before you add the second screw, we need to slide on the pulley arm as shown. It should fit snugly against the bracket, then you can add the remaining screw. Now we're going to add the stepper motor for the new second X-axis. Using a spanner and Allen key, remove the bolt for the top wheel on the bracket. Carefully remove the wheel and its 2 spacers. Now as shown, push the stepper motor into place so that holes line up. This next part is a little fiddly as you need to reinsert the bolt, spacers and wheel back into the bracket. I find adding one piece at a time is the easiest method. Slot the nut into place and give everything a really good tighten. Next up are the belts. Start with a new carriage and feed the belt through the pulley arm as shown, ensuring the teeth mesh with the pulley. We're now going to loosen this screw and remove the belt tensioner from the carriage. Insert the belt into the tensioner with the teeth facing up. Place the stopper on top and gently push them back into the hole. You should get a really snug, firm fit that isn't going anywhere. You can now run the belt under the cables and around the X-axis motor and back to the carriage. Now reinsert the tensioner as shown. You should be able to see a hexagonal hole on the other side of the carriage. This is where the nut is that the screw tightens against. To keep this in place as we tighten the screw, use a large Allen key or screwdriver to hold the nut in, as you see here. Once you feel it take, you can remove the tool and further tighten the belt. You want it to be taut but not too tight. If you gently move the carriage, it should run smoothly with a little resistance from the belt. Now to the new belt for the original carriage. As the axis is wider, we'll need to use this new longer belt from the kit. Insert the end with the clip onto the carriage, ensuring the teeth face into the bar. Thread the rest under the wheels around the end, back under the wheels, and around the motor. You can now install the stopper like we did before. Before you attach it to the carriage, we need to reinstall the tensioner for this axis. This time we're going to install it on the back under the pulley arm. This should be loose for now and just held in place. Now insert the end of the belt onto the carriage. Finally, tension the belt, as I'm sure you will have done many times before. I prefer to carefully use a screwdriver to get a good amount of tension. Once again, the carriage should move freely with a little resistance from the belt. The new upgraded X-Axis is now complete. You can carefully place it back on the printer and slowly spin the Z-axis to lower it back down. Now is also a really good time to feed the cables into the cable arm to hold them neatly out of the way. To finish off this section, we need to add the remaining parts to the top bar that we removed earlier. Make sure the larger holes are facing upwards and slide on the new extruder. Next, add the two filament holders. If you're holding it like I am, the logo should face away from you. And finally, the extra extruder holder. You can add the plastic end cap back on and insert what I call the dog bone to securely keep the spool holders together. Place the top bar back on the printer with the extruder hanging over the back of the Ender 3. Securely screw it back into place with those screws that we removed earlier. Take the PTFE tube from the IDEX carriage and screw it into the new extruder. Once tight, add the Bowden tube clip to ensure it does not move during printing. You can now plug in the remaining 3 cables for the new stepper motors and end stop. Feed the new end stop cable under the power supply, plug it in. The X-Axis 2 cable can go underneath and plug into the stepper motor. Make sure there's enough slack for it to move up and down. Finally, the new Extruder 2 cable plugs into the extruder we just installed at the top. The last thing to do before we start printing is to move the original extruder to the top of the printer. This will reduce the weight on the X-axis since we added a new motor. Because this location is a tiny bit further away, we need to swap out the PTFE tube for a slightly longer one provided in the kit. Start by unscrewing the tube where it joins the hot end. Once removed, press down on the plastic part of the connector and pull out the tube. At the other end, remove the Bowden clip and perform the same action to remove the tube from the connector. As you can see, the new tube is a little longer and this is just enough to allow the axis to move around freely. Start by pushing the new tube into the extruder connector and returning the clip. Now at the other end, push the connector we removed before onto the tube. About 3 cm should be showing at the end. Place the tube back into the hot end and begin tightening the screw. Don't screw it all the way in, just enough so that it is securely connected. Now push the tube as far into the hot end as you can. We want it to butt up against the nozzle. To ensure a super tight fit, you can now return the Bowden clip and tighten down the connector. This last few millimeters of tightening will ensure you have a nice snug fit. Now that the Bowden tube is changed, we can move the extruder to the top. This is just a matter of dismantling the extruder. Be sure to hold the stepper motor underneath as you release the last few screws, as otherwise it will just drop. Now place the extruder at the top with the Bowden tube facing out. Place the stepper motor underneath and reassemble everything as shown. Of course, if you have an upgraded extruder, this will look a little different but should work all the same. To finish off this section, you can install the red cover cap on the front of the extrusion. This is also an ideal time to check and tighten the eccentric nuts. First of all on the Z-axis, and then on the new X-Carriage. You want to ensure there's as little wiggle as possible. Congratulations, you're all done with the hardware. That wasn't too hard, right? All you have to do now is a little calibration and you'll be ready to roll. We'll cover all of this in the final section. Part 4. Calibration. Before you turn the printer on again, we need to load the new firmware. This is really easy. Take the SD card that was included with the kit and plug it into your computer. In there you'll see a file called IDEX firmware.bin. All you need to do is rename it to firmware.bin. When the printer boots up, it will see this file, recognise it as the firmware update and load it into the motherboard. So take the SD card, reinsert it into the printer and then turn it on. Once it's booted, we can test everything is working by going to Motion, Auto Home. Both carriages should move and home to their respective sides. You now have a fully functional IDEX Ender 3 printer. Load in some filament and we'll finish off by calibrating the two heads. As you know in 3D printing, a level bed is absolutely vital. This is even more true with two X-carriages. But don't worry, if you follow these steps you won't go wrong. As we've completely disassembled a lot of the printer, it's a good idea to start with a rough paper levelling to ensure we're in the right ballpark. Move the first hot end over each screw position on the bed and adjust it up and down until it just slightly catches a piece of paper. I'd always say it's better to be a little too high than too low at this stage. Once you're happy it's fairly level, run the Extruder 1 levelling squares print on the SD card. This will print a square directly over each levelling screw on the bed. You'll also notice that despite adding a new carriage to the axis, the printer can still reach and print on the entire bed. As it's printing, you can adjust the relevant screw to ensure you're getting a nice close print, especially on the infill. You're looking for a nice even print like you can see here, where each of the layers are adhered to each other well. You can see I can't easily split the square apart. You can repeat this print a few times if you like to ensure you get it dialed in perfectly. The better you level the bed now, the easier everything else will be. Now because we have two independent hot ends, we can't just adjust the bed for the second hot end. So instead this new second hot end can be raised or lowered with a screw. This way we can get it as close as possible to being the same height as the first hot end. Start by moving it over the closest bed screw and put a piece of paper under it. Now insert an Allen key into the top as you can see here. Very slowly twist it clockwise to move it up and counterclockwise to move it down. Once again, it's better at this point to be a little too high than too low. As we're happy the bed is already level, we only need to do this at a single point. Now, once again on the provided SD card, you can print the Extruder 2 levelling squares. In the same way you did with the first print head, watch the squares very closely and gently twist the screw up and down to get the perfect level. If you've levelled the bed well, you should find that after the first square is tuned, the remaining three print just fine. Of course, if you find it just isn't working, reach out to me and I'll be happy to work through the challenges with you. Now that both hot ends are levelled, we have one last calibration to complete. This is the tool offset. What we basically need to do is tell the printer exactly how far in the X and Y direction the two hot ends are offset from each other. Don't worry if this doesn't make sense right now, it will as we start the calibration. To start, run the XY calibration cross print from the SD card. You'll see it's only a quick print, with both hot ends printing a circle and cross where they believe the centre of the bed is. In my case, the second extruder is the one that printed in black. I need to measure how far off it was in the Y direction, so here it looks like 11.5mm too far forwards. And in the X direction it looks like it's too far left by maybe 2mm. On the printer we go to Configuration, Tool Offset and input our values. For the Y I want to move it backwards, so I need to take away from the existing value. So here I'll change 0 to -11.5. And for the X I want to move it to the right, so again I take away from the original number. so 275 becomes 273. Before I move on, I'll store the settings, otherwise they'll be lost when I turn off the printer. Now I can run the same XY calibration print again. And you can see here we're much closer now. I'd say it's a little too far back now in the Y direction, so I'm going to add back 0.5 millimeter. And maybe add 1/4 millimeter to the X direction. The closer, more accurate you get the offset, the better your two-colour prints will be. If you intend to use your IDEX printer for more duplicate and mirror prints, this step is not as important. Congratulations, you made it! Hopefully that wasn't too difficult and you learnt a little along the way as well. Now comes the exciting part, IDEX printing. The first print that is good to start with is a mirror benchy. As you can see, both print heads print at the same time in perfect mirror of each other. This means in exactly the same amount of time you get double the output. This is excellent if you're producing multiple copies of the same thing. If you want two items at the same time but not mirrored, there's also a duplicate mode. I have another video that follows this one and walks you through how to slice prints for an IDEX and use all of the available functions. Also, as we've not lost any print volume, you can still run regular Ender 3 prints on your printer. Once you've got your two benches, let's try a two-colour print. The two-colour extruders file is a nice one to start with. You may also find you get a small amount of extruder skipping during two-colour prints. The odd skip every now and then is not unusual and nothing to worry about. This is primarily caused by the very tiny height differences between your two print materials. When you're dealing with layer heights of 0.2 millimeters or less, a small variation between your two heads can actually have a big impact. If you find it's happening a lot, you can use your Allen key to raise the second head ever so slightly. Remember, even a tiny movement of this screw can be enough when you're talking about 0.1 and 0.2 millimeter differences. If you're feeling adventurous, there's an Ender IDEX sign print. This is much bigger and will take a fair bit longer. Finally, let's end the video with the two-colour benchy. Now be warned, this is a lot more challenging to print than a regular benchy. For the cabin section especially, there are a huge amount of retractions and tiny pillars. Also, good bed levelling, X and Y offset are essential here. If you find you're getting a lot of string in, I'd suggest first taking a look at your filament, as this print will really push the limits of a poor quality PLA. So that's it. I hope you found this video useful and you're excited to start printing with your Ender IDEX. I'd really love to see what you create with it, so please do post your prints on social media channels. And as always, I'm very keen to help with any problems, questions or challenges you might have. Go to enderidex.com to find out more and find out how to get in touch. Otherwise, thank you and happy printing.